Claude.
It's not. Sorry, it is
No, it's
recording.
Mhm. Welcome everyone to Cloud Data Driven online user group meeting. Okay, and we have a very great session today. I'm sorry I forgot to update on the session. That's my mistake, and I apologize. Let me quickly fix it. Uh, okay, just just give me a second. Our session for today, it's a very good session. Just let me see if I can quickly update it now. Okay, great job. So, welcome everyone. One more time, it's a pleasure to have you all to Cloud Data Driven online user group meeting where we meet every uh, Thursday at 12 p.m. If you would like to connect with us, you are free to, for example, you are free to scan this slide, okay? And also this session will be recorded and will be posted to our YouTube channel in case if you would like to go and revisit the session, you are free to do that. And when we publish it, we will let you know. Great job. Okay, for your information, this community is fall under data-driven community. Under data-driven, we have cloud data-driven. We have, first of all, feature data-driven, which is a yearly conference. It is a place where we bring about 60 or more different speakers talking about data, AI, and visualization. For this year, it is scheduled to be on September 24th. We highly suggest you to go and share this event with your peers. We have our online user group meeting, which is every Thursday at 12 p.m. We have a tons of session lineup. We highly suggest you to go and visit our website, which is data-driven-community.com to register for both feature data-driven and our weekly user group meeting. To register for yourself for Feature Data Driven Summit 2025, feel free to scan this QR code. Okay. For example, this is if you want to stay updated with our latest upcoming summit when it comes to feature data driven, feel free to scan this. Okay, and then the, this community is managed by four of us. Wonen is the co-admin, and he's the primary person that handle in and out in terms of work decisions and communications. However, Wonen work very close with Anna along with Dipti. We used to have Koyela. She used to support us, but she's still there for some reason. She's a bit busy. She cannot be with us, but she's still there in the background helping us. And I am Jean Joseph. I work for Microsoft as a technical trainer, mainly focused on data and AI. Yeah, but my background is data and AI, mainly into administration and engineering. I've been in IT for about 22 years. Yeah, and I am the founder of this community and one of the organizers. If you would like to connect with me, you are free to scan this QR code. Yeah, that's all for the four of us. Here's the thing, I'm a big fan of the community, and I hope, for example, you are too. So feel free to share our event with your peer along with Data.com. That's going to be in Seattle. If you haven't registered yet, we highly suggest you to do that. And we also have Sikobit on the way, which is scheduled for this June. We highly suggest you to register as well if you are in Europe. Okay. And this is an online event. If you would like to be part of this event, feel free to bank that and register as well. And we also have Visual Studio Live, Microsoft HQ, which is scheduled for August this year. And we have Ignite. I am looking for the date, and I'll be happy to share that. And we will email you about the latest updated as well. So with that said, if you have if you would like to engage, we have the chat. If you have a question, feel free to raise your hand, okay? And I would like to say special thanks to Andrew. Andrew, it's really a pleasure to have you today. Andrew, feel free to share the screen, introduce yourself, and start with the presentation. Thank you.
All right, thank you for having me today. Let me share my screen here. Fingers crossed my internet keeps up. I'm at Snowflake conference today, so I want to, I'm on the hotel Wi-Fi, but so far so good. So a theme for today and for the last, I'd say 6 months as I travel around and speak with executives and with the data community is really, how can I power AI? And what role does data play? And then to avoid vendor lock-in, how can I use open source products in order to do so? So these are all awesome questions. I'm going to focus a little bit on agentic AI today, just because agentic AI in the last 2 months, I'd say, has really taken off. And there's a few reasons for that that we can get into. Okay, there we go. So my name is Andrew Madson. Feel free to connect with me on LinkedIn to carry the conversation on. Before becoming a education evangelist and tech startups, I led data teams. So I was vice president of data at data and machine learning at JP Morgan, senior director of data at Arizona State University, and a bunch of other places. I was previously head of DevRel at Dremio, and now head of education and evangelism at Tobico, the creators of SQL Mesh and SQL Glot. On the side, I'm a graduate professor of data science and data analytics at a bunch of different places. And you can feel free to catch up with me on LinkedIn, YouTube, anywhere really. Where most of my activity happens is on Slack, so feel free to join me on Slack. I have that pinging my phone constantly, and I'm responsive there. So if you have any questions or want to talk, LinkedIn's fine. Slack, I'm much more responsive. I co-wrote the Apache Polaris Definitive Guide. That's a open source catalog for Apache Iceberg that we'll talk a little bit about today. So feel free to grab a free copy of that. It's the early release version, full release coming out soon. It's fully written. It's just finishing up the publishing there. So if you'd like a free book, feel free to grab that one from O'Reilly. I've got a few more books coming out here shortly, and I'll make sure that if there's any free copies of those, that I'll make those links available. I'm writing the guide to AI-ready data, as well as another O'Reilly book I just signed the contract for 2 days ago. Okay, enough of that. So what's the opportunity? Why are we talking about AI? Well, it's all over the news. We can't go hardly a day without hearing about AI. But why? Why is there so much there? Well, the opportunity is immense. I think that we can all imagine ourselves 4 or 5 years ago doing the work that we do, and then comparing it to the work that we're doing today. And in some way, it must have changed. It must have changed our workflow. It must have changed something in our lives in a way that 4 or 5 years ago, we probably couldn't have imagined. I know for me, using the new Google video creator, VO2 or 3, I can't remember which one it is. They move so fast. Sora from OpenAI, incredible. Now the operator from OpenAI is, it can literally build websites for you. We've got Replit, which, I think pulls Claude, lets you literally just build apps on Postgres. It's literally changing the way we work, and it's also helping us reimagine the way we work. We're doing things that we couldn't have it even imagined that we could do just a few years ago. And Gartner, in a recent report, said that, not just are we talking about AI, it's not just a fad, we're putting money into AI. It's the top investment for most organizations right now, or at least one of the top 5. So similar to like the digital transformation of a few years ago when it was, let's move to the cloud. Many data initiatives are bottom up. We're begging for change. We're begging for better infrastructure, better data quality, whatever it is. This is a top down, hey, coming from the board level, here's money, go do this. It's strategic importance. And that's why we saw a huge lift in digital transformation, board level down. We need to move to the cloud, or at least move some things to the cloud. AI, board level down, hey, go do AI. I was at ASU when President Crow, the president of Arizona State University, he was the first educational organization to sign a contract with OpenAI. It was super early. ChatGPT 3.5 had just been released, and he signed a contract. And then our directive for President Crow was, "Hey, go do AI." So it's coming from the top down, and that's one reason we're seeing a lot of AI is that the investment is there, and now we've got to figure out how to do it sustainably, and do it in a scalable way. And when there's money involved, right, when it comes from the top down, there has to be a result on the back end. What are the leadership, what are the boards expecting as a result of doing AI? It's not just for, giggles. It's not just to feel good and pursue something that they're interested in. They want to see output. They want to see increased innovation. They're looking for productivity. And they're looking for, of course, revenue on the back end. It's a strategic investment. They're hoping, they're planning that AI will in some way increase the bottom line. And so you can see that there was a recent, I believe it was Gartner again. Bark also had a recent survey on this, Bark Research out of Germany, that what are the top like actual implementations of enterprise AI, like not just proof of concepts, like what is actually being implemented. The number one implementation of AI was coding copilots, which makes sense to me. I'm seeing those everywhere. We use them at Tobigo. Most organizations that I talk to, even with, it's not just for new engineers or software engineers or data analysts. That's sometimes how it's portrayed. Our expert engineers are advocating for using it. Like, I mean, experts, like people who have created frameworks from the ground up. They love it. They love Claude Code or Cursor or whatnot. So it's really augmenting those who understand coding. It's helping them move much faster in a more productive, scalable way. The second use case was chatbots. I think we could envision that with either internal chatbots using like a RAG model, pulling organizational context in to answer questions about processes or organizational information, or customer-facing chatbots. We've seen some good and bad examples of implementation of customer-centric chatbots. And the third most popular use case was automation. So automating rote processes that don't necessarily need human hands on them. It's the same thing over and over, fairly simple workflow that can just be automated, maybe by an agent. So those are the top 3. And those really do align in my mind with what executives are saying. They expect their output to be innovation, productivity, growth. They're trying to find that efficiency and then augmentation of their workforce by using AI. So I'm going backwards. Apparently, I need to learn how to click. But when we say AI, it's almost become a buzzword. Here at the Snowflake Summit, like AI is literally everywhere. I don't think I've seen two letters next to each other more than these two this week, and I'm sure next week at Databricks will be exactly the same. And it's been that way for a while, right? It's not something new. So what really is AI? It feels a lot like this, right? I felt a little bit this way when I've met with executives across the world in private and public sectors. Like, we need to do AI. I'm like, okay, let's talk about like, what is AI? Like, what do you actually mean when you say AI? Um, I'm not that old, but not that long ago, AI was really deep learning. That's kind of what we meant when we said AI. We're like, oh, this is going to be neural networks. That's really what AI means. There's other definitions of AI, like Cassie Korsakoff, formerly of Google. She describes AI as like an all-encompassing definition of like analytics, machine learning, and deep learning, and now generative AI roll up into it. So there's different definitions, but I think it's important when you're talking with stakeholders or even yourself, when you think through like, okay, AI, what is it? What are we actually trying to accomplish with AI, and how are we defining it? I was meeting with the head of AI for a giant government organization, and he defined it very well. And just that it was anytime a computer can act independently in a way that a human could. I love that. And his AI strategy is built around that. So it's important to really define, like, when we say AI, what do we mean? Is it just generative AI? When we say AI, do we mean we need a generative AI strategy? Or is it more all encompassing, where we're going to roll machine learning in there, which we probably should, or augmenting or automating some analytics, which we probably should? So getting down to the root of like what actually is AI is super important. So the way I look at it is really machine learning, deep learning, natural language processing, which generally includes generative AI, but now it's even expanded to the multimodal models have become much more competent. Before, multimodal models were difficult to work with, meaning that they can use text, images, sound, video, either ingesting them or creating them. Before, they weren't that great. Now they're much better. But regardless of what type of definition you're using for AI or what type of AI that you want to pursue, it becomes really tempting to just focus on the model or the type of AI that you want to use. Finding the next, the latest and greatest Hugging Face model, or reading the announcements of, oh, Google just launched this, or Claude 4 just came out, or ChatGPT has a new model. It's really tempting to just focus on that. But similar to machine learning, it's a system. You can't have the AI model in isolation. And it sounds intuitive, but really when I meet and consult with organizations, it's often forgotten. And I think if you've been in data for any time, if you're in analytics, or if you're in data science, if you're a data engineer, data is often an afterthought, and it really just cannot be, especially with AI initiatives. So we've got the model, of course, and we're really good at doing CI/CD around a model. We're really good at tracking feature drift, model drift, constantly improving it, making sure that we're measuring precision and recall. And there's some more complicated ways to measure generative AI efficacy. We're really good at watching the model, but the model is only as good as the overall system. And the other half of the system is the data. The data has to have just as robust a process in curating and maintaining and improving it as our model does. That's the only way to build a scalable and sustainable AI model. It's exactly the same as with machine learning. But with AI, the risk is much higher, in my opinion. I think we've seen that because if you think about analytics, machine learning, where's the human in the loop? Like, what are the guardrails and the checks? If you have an analytics workflow, a typical analytics workflow, we've got a software engineer who's enabling a source to drop the data in a data lake, some storage database, whatever it is. Then we've got a data engineer who's then ETLing it or ELTing it, right? They're moving it, they're curating it, they're creating some type of data set, they're deduplicating it, normalizing it, and then potentially they're doing it again, or they've got an analytics engineer, some other hands on it. It's moving several times as it becomes much more curated as it gets closer to the business use case. Then we've got an analyst who picks it up and builds some type of dashboard or report to serve a business need. And then we've got the business user who's then picking it up and interpreting that information to inform their business decision. There's a lot of hands along that pipeline, along that value chain from source creation to business decision and value. A lot of hands. It could go, if it goes wrong at any point, there's one or two people or groups along the way who can identify that. And ultimately it gets to the decision maker who's going to use that to inform their decisions. Can it go wrong? Yes, but there's guardrails and people in place. Similar with machine learning, maybe less so. So we remove the human from the loop a little bit, right? We've got a similar value chain. We've got a software engineer helping with ingestion. We've got a data engineer curating it. Now we've got a data scientist building some type of model. Maybe it's a predictive model. And then we've got the results that are, again, probably just informing a business decision. So if we build like a churn model where we're trying to predict churn, it's not typically automated with the business decision on the back end. So we may predict that XYZ, this cohort of customers is going to churn, but we're providing that information to somebody to then make that decision of what are the next actions. Or maybe if it is an automated decision, maybe it's a low risk automation workflow on the back end. Maybe it's putting them into a marketing nurture campaign where it's just emails going out to try to re-engage people. Like it's fairly low risk. The data scientists are measuring and watching the model drift. They're looking at the precision and recall or the F1 score of the model. There's a robust system in place. So we've got hands in place. Can things go wrong? Definitely. With AI, the way we're using it, the human is further removed from the loop. So in an AI workflow, depending on what it is, if we do a chatbot, for instance, we've got the software engineer ingests the data engineers are curating the data, the AI engineers are now building the model and deploying it, or the AI model deploying it, but now the chatbot's acting on its own. There are ways to measure it, but I mean, it's looking backwards, right? And at the scale that it can act on its own is much higher. So it could have tens of thousands of conversations before we recognize something's wrong. And then we got to shut it down and go, fix it, which we've seen happen a few times in the news where either a chatbot went off the rails, or Amazon had all these crazy postings that they were using to like describe their products on the Amazon web store that just were completely inaccurate. And you could tell that ChatGPT had written them because I think it said that ChatGPT had written them, and it was at a very large scale, and that was tough for them to roll back. There was an instance in a Nordic country. I think it was Iceland, but I'm not looking at my notes, so I can't remember. But a Nordic country where they used AI they used a machine learning model to, one, determine whether or not low-income families were eligible for assistance, and they did a look back on it. But then they put those results, instead of having a human look and make the next decision, they had an AI look and make the next decision. And unfortunately, it was incorrect, and it went and told thousands of families that they were not eligible for assistance. And not only that they actually had to pay back the government the assistance that they had received for the last several years. And it was incorrect, and it was a big issue. It caused a lot of stress for people. So All that to say that the risk of having AI go off the rails is much higher than the risk of having analytics or machine learning potentially go off the rails, just because we've removed the human from the loop a little bit further through AI. So if we're only optimizing for the model and then launching it, we can run into these issues. And data is really going to be the core of being able to have the sustainable system. If we look at the growth of OpenAI's GPT, now ChatGPT, GPT-1, how is it built? Well, starts with just under 5 GB of just raw data. What can it do? At the time, it could do something impressive for us, because really models couldn't really do this before, but not super impressive compared to today's standards. Now we get to GPT-2. I mean, even GPT-2 was insanely hard to use. That's why you haven't heard about it, because it wasn't that great. It wasn't that useful. But we've almost 10x'd the amount of data, and we've increased the quality of data by providing human filtered data. What can it do now? Much more helpful examples, but it's not replacing anything that we already have. We have other tools and resources that can do these same things. Now we start getting into GPT-3. We more than 10x the amount of data, and it's heavily filtered. So down, 45 terabytes of data, heavily filtered and curated down to 570 gigabytes. So now we're working with a massive quantity and very high quality of data, and it can do much more. 3 starts to become more useful, but 3.5, where it becomes Chat GPT, because we built that useful interface around, OpenAI built that useful interface around it. And 4, that's when I would argue the turning point is for generative AI, because 1, it becomes much more easy to interact with, and 2, the utility of it is much better. Now we can start to do things that we couldn't do before, where the previous iterations were different ways to do things that we could already do. And what do? They have an insane amount of data, and it's the highest quality. They've got human feedback. So that we know it's an insane amount of data because, 1, we know they release the number of billions of parameters that they train their models on. And 2, we've heard the scandals about copyright ethics around what you can and can't scrape and how to train things. But what got us from 1 to 4, and now it's even continued on, right? There's more models and different kinds of models. Each of the underlying models, it's really a transformer model. That hasn't changed. When transformers rolled out, right, the Google paper, attention is all you need, that's amazing. Transformers are insanely helpful. It's one way to build generative AI. There are others, but transformers are still, I would argue, the core of generative AI models. Transformers stayed the same from 1 to 4. What changed is the quantity and quality of the data. That's what got us from 1 to 4, is improving the amount of data we have and also the quality. And it's the same, I would say, for any AI system. It's really machine learning and analytics. You may be thinking to yourself, well, like, duh, like we've been saying this for years. Like whether you're a data engineer, data analyst, data scientist, anybody who works with data, we've been arguing this for years, that we need better and more data. It's a data quality problem. But what's holding us back? Like, what causes these data quality problems? Well, there's a lot of things that we're going to get into, but ultimately, we say garbage in, garbage out, and that's true, because when I was leading a machine learning team at a large bank, I had the mindset, and I've found this in other organizations, which is a bad mindset, that I just really was hoping that my model would be so awesome that it would overcome my low quality data. It was, I was using the data lake. It was all over the place there. And because of the nature of the data lake at that time, there was no schema compliance. It wasn't ACID. So it was just raw data in there, and we were just running models over it, hoping that the model would be so awesome that it could weed out anomalies. And it worked okay, but data quality wasn't super top of mind, because we just were thinking to ourselves, oh, we need so much data quantity is going to be more important than quality, and we'll just, fine tune the model and make it so that it's so awesome that bad data won't super matter. It's a bad mindset, but I do see it prevalent throughout many organizations. But I think that's starting to shift. 72% of CIOs think that data problems are most likely to jeopardize their AI ML goals. And Gartner agrees. Take Gartner for what it's worth. Anytime I see a statistic that ends in a 0 or a 5, I'm immediately skeptical. I'm like, okay, we're probably making up statistics now, but it's likely directionally correct. I would note that these statistics have just changed. So in November, Gartner said 60% of AI projects will fail. That's their prediction. And 30% of that will specifically be because of data quality. Now they've increased it, and they're saying approximately 70% of AI projects will fail, and 60% of all AI projects will fail, specifically because of data quality. So they've doubled their estimate of projects that are going to fail because of data quality. And I believe that's because they have more data. Now we've seen more proof of concepts go out into the wild and try to be employed and fail. The Gartner analysts are constantly meeting with companies, constantly meeting with vendors, and now they have more data, and they're saying data quality is a giant problem, and it's really causing all of these projects to fail. And that was just a couple months ago. So just in a few months, they doubled their estimate of AI projects that are going to fail, specifically because of data quality. There's a lot of definitions around data quality. For the purposes of this conversation, what I mean is accurate, consistent, complete, timely, relevant. There's lots of different submetrics you can look at. You can really get in the weeds on data quality. Data quality is really, in my opinion, needs to be aligned with the project. Some projects don't need absolute truth on the data, and that's just a fact, and that's fine, and that frees you up. Some projects need absolute truth. There's no room for error on some projects, and it's important to know that when you start building data quality systems or start trying to curate data to power either AI or analytics or whatever it is, you need to understand what's the ultimate output of this project. What are we actually trying to do? And what role does data play? And what role does data quality play within this? Is it okay to have some data quality that's loose on one of these metrics? Because sometimes it's not possible to hit all of these metrics. Ideally, we can, but if you can't, you have to make trade-offs and then understand what those trade-offs are. So one way to do that I'm seeing more and more is through data products, which has become a little bit of a buzzword. And lots of vendors that I've spoken with define data products in lots of different ways, and they align with the capabilities that vendors provide, which is some smart marketing. But typically, a data product, if you're going based on the book, the Definitive Guide to Data Products, or no, Definitive Guide to Data Mesh, which defines data products inside there. It has to be accessible, governed, timely, trustworthy, valuable, and owned. So these are difficult characteristics to implement in a silo. It has to be part of the overall data strategy and have a lot of buy-in from leadership on down in order to make it scalable, including the business. The business also has to buy into data products, to be honest, for it to actually work and be implemented in a sustainable way. But data products are an excellent way of at least thinking about how we treat our data and how that links to business outcomes. A lot of the engineers that I've worked with, or the teams that I've led, one of the things I learned early on is that it's easy to feel like you're in a bubble or in a silo, that you don't really understand the value of the work you're doing on the back end. Like, you're creating these awesome pipelines, you're maintaining these giant tables, sometimes petabytes of data, and you get your pager duty call, something broke, let me go fix it. But you don't really understand, like, how's the business using this? How does it impact them day to day, and what value are we actually deriving from this? So having that data product mindset actually makes this much more natural. So one way, in my opinion, to implement data products in an enterprise is to have open source data architecture, because open source brings a lot of value. When I first started in data, open source, maybe it was just the companies I worked in, open source wasn't highly valued because there was risk. So I started in financial services, which was heavily governed uh, and scrutinized and regulated by the government. So we only used, or for the most part, we used proprietary products. We used SAS, we used SPSS, we used Alteryx, we used robust, expensive solutions because we, I don't know, open source products were considered maybe untrustworthy or second tier. I mean, we were using SAS instead of R or Python to run predictive models. And then there was a shift, at least in my industries. There likely were more open-minded industries who were doing this earlier, but now open source are much more accepted and often considered the ideal solution if you can get what you need from an open source architecture. So it allows you to avoid vendor lock-in. It allows you to be able, depending on the open source license, right? There's different ways that it's structured. It allows you to crowdsource and get the group mentality to build a product at a community level, which can really increase innovation depending on, again, how the license is structured. There's different foundations. So you've got like the Apache Software Foundation, where it has to be owned by the community and it's governed by a group of companies. Like one company cannot own an Apache Software Foundation project. You've got the Linux Foundation, where like Unity Catalog and Delta Lake are a part of, where that can be controlled. It's open source, right? But it can be controlled by a company, in this case, Databricks, which there's cases to be made for each. You've got the MIT license, you've got BSD. You can have an Apache 2.0 license and not be an Apache Software Foundation official project. So there's different trade-offs, right, in understanding open source. And sometimes it matters and sometimes it doesn't. But if you can get open source architecture, it gives you control. Because what happens if maybe, let's say you're in a company-controlled open source project. If they stop supporting it, or they start doing things you don't like, or they change the license on you, you can fork that project. Like, you have the source code. If you're an Apache Software Foundation project, like Apache Iceberg that we'll talk about, or Apache Polaris, where the book is written on, that's not going to die. Like, there are people on that committee. There's companies invested in that. There are thousands of contributors from all over the world. So there's a lot of benefits to having open source architecture. So specifically for building a data product in an open source way, here's an example of how you could do it, right? So you can do storage layer, I don't know, S3, do something open. I know MinIO just changed some of their underlying free tiers, so maybe I don't know, you do trade-offs. The metadata layer, you can use Apache Polaris, open source catalog. The transformation layer, now you can do things like SQL Mesh, DBT Core. Those things are open source, both under Apache 2.0 licenses. For the compute and query engines, you could do DuckDB, you could do Apache Spark, you can do Trino, which can read from multiple sources at once. And then the AI and consumption layer, there's different ways to do that. We have open AI models. We've got the Llama models. There's so many on Hugging Face. There's tens of thousands of models on Hugging Face, many of them very, very good that you can use. Some of them very specialized in use cases. I want to talk specifically about Apache Iceberg because in the open table format, Apache Iceberg seems, in my opinion, to be the winner. It seems to be the standard that most companies, if they go into the open table format, are adopting. And what does that mean? What's an open table format? So if you think back to when I was talking about, oh, when we built this machine learning model that was just trying to overcome the poor data quality on the data lake because the data was just in there. It's a bunch of files just all over the place, and we were just reading them and hoping the model could overcome them. Data lakes are awesome because now we can put anything in there. In a database, in a data warehouse, typically it's just going to be structured data, rows and columns, which is what's powering our most analytics systems. But with the rise of the internet, now we've got all this text. Now we've got all these images. Now we have videos. We have all this additional data that we'd like to store. And so with the move to the cloud, suddenly you could scale your storage without having to buy hardware, right? You're using somebody else's computer. So there's a much lower barrier to entry because you don't have to buy hardware to build your infrastructure, right? You can scale horizontally now without also having to scale vertically. So we started just storing everything we could. Good idea, maybe not executed in the best way. I'll give you an example, because when I took over data at a large organization, and I was trying to figure out, I took over data analytics, not all of data. So I was trying to figure out where is the most common data that we're using, because they didn't have a data catalog, which may tell you a little bit about that company. And I came across a giant source of data, and it was just growing, exponentially, just tons and tons of data every day, multiple times a day. And so I was looking at it, I'm like, what is this? Oh, it's key card swipes. Every door that you had to go in and out of at any time, you'd swipe your card, it would track it, and it would drop into the data lake. I'm like, okay. And there were hundreds of thousands of employees. Like, okay, so imagine the size of this data set. Okay, so why are we tracking this? They're like, oh, it's valuable. Like, okay, what are we using it for? They're like, nothing. Okay, and I think that's a lot of what's in our data lakes across industries. It's just tons of information that's maybe not being used, and some of our data lakes have become, quote unquote, data swamps. What an open table format does is helps us organize and bring the qualities of a data warehouse to the data lake. So if you think about how a data warehouse works with ACID transactions and those guarantees, it has schema enforcement, it has partitions, it has high data quality, right? It's normalized. That doesn't exist in a data lake on its own. But if you can organize that underlying data, the Parquet files, you can't tell a data analyst to just go to the data lake and, read these JSON files into your dashboard. It's not going to happen. They're looking at it, and these 30 JSON files might actually be a table. But you don't know that because they look like individuals. A table format organizes it so that those 30 JSON files are organized as a table. And that's what Apache Iceberg does, is it sits on top of your data lake. It's a structure. Nothing's stored in Apache Iceberg. It's a way to organize your data. It's a specification. You can organize the data in your data lake in Iceberg tables so that you can now access your data lake in the same way that you would access your data warehouse, with the same type of data quality. It has schema enforcement, partition evolution, hidden partitioning, ACID compliance. Really, really awesome benefits, because what were we doing before? We're dropping data in the data lake, and then we would have to ETL it probably several times. We landed in a data warehouse, which is great, but now we've got data in two places that can create data quality issues, potentially. Now you can just land it in one place and use it in one place. If you want to, you can just do all your analytics, machine learning, AI directly on the data lake with all the same characteristics that you would have in a data warehouse, all those benefits. So Apache Polaris is associated with Apache Iceberg. Do you have to have a data open source metadata catalog on top of Iceberg? No, but you really should. It's very few cases have I ever seen where a successful data strategy using Iceberg didn't have a catalog. Uh, I think it's just been really small scale. We're trying it out where they didn't have a catalog. So how this works is you've got your data layer, right, where your JSON files organized by the Parquet. You can do Orc or Avro, but I recommend Parquet for lots of reasons. If you've got your Parquet files in the data lake, now on top of that, Apache Iceberg and the catalog are going to understand, okay, which files are actually tables, and we're going to organize that in a manifest. Now we're going to take all these manifests and we're going to organize them by manifest lists. Now we're going to organize these manifest lists by metadata, the metadata catalog. And then on top of that is the data catalog. So then when you query the catalog, it goes through, it does query pruning super fast. It can find, in a columnar way, exactly which data you need because it's organized through this structure. And it's very efficient. So Apache Iceberg rolls out of some very talented engineers at Netflix who now work for Databricks, Ryan Blue, Daniel Weeks, and team, who struggled with the volume and quality of data. They really wanted to build a system that was much more efficient than what they had available to them. They wanted to do data analytics directly on the lake without having to do all these ETL process and shift storage all over the place. So that's why they created Apache Iceberg. Delta Lake was created by Databricks for a similar reason at the same time. I think Delta Lake might have been a little bit earlier, but maybe by 6 months. But if you know a development life cycle, they were developing them at the same time. And Apache Hootie rolled out about the same time as Iceberg and Delta Lake, which came out of Uber. Why do I generally recommend Iceberg? Well, Delta Lake typically just works best in the Databricks ecosystem. So if you only have Databricks, maybe Delta Lake is the way to go. However, Delta Lake can also generate Iceberg metadata that can be read by Iceberg catalogs. So Delta Lake is kind of moving towards the Iceberg format. Hootie is much more transactional in that it think of like streaming data. Hootie's much more concerned with like what's the most recent data that's been received and how can I access it quickly? And it's not concerned with historical snapshots of the data. It's not really concerned with like historical analytics. It wants to know where the Uber car is like right now. It doesn't really care where the Uber car was a week ago. For analytics and AI and machine learning purposes, generally Iceberg is more ideal because it is more focused on that historical snapshot, being able to do cubes and OLAP on historical data in a very efficient way. So that's where Apache Iceberg's going. Ryan Blue, the creator of Apache Iceberg, now, as I mentioned, works at Databricks and has hinted that Apache Iceberg would potentially, encompass Delta Lake, and that there may just be one table format between the two of those, which would be great because then you don't really have to choose. So anyway, long story short, if it's like a 10-second, what is a table format? It's a way to organize your files in a data lake with all of the benefits of a data warehouse that enables you to just do all of your analytics, machine learning, AI directly on the data lake. So where does SQL Mesh come in? So SQL Mesh is a open source data transformation framework, similar to DBT Core, except it adds state and rollbacks, version control, all of those things inherently built in. So you can do incremental modeling, which at scale is insanely important so that you don't have to refresh an entire table every time a little new data is added. I use SQL Mesh. One, I'm biased because I work at Tobacco and we created and maintain SQL Mesh. It's open source Apache. But two, the incremental modeling and understanding the state of your data is super important, especially at scale. So with AI, you're constantly receiving new data and you need to transform it and refresh your model, but you generally just want to refresh or query the part that is new. You don't want to have to rebuild your whole model from the ground up every single time that you receive a little bit of new data. It wastes a ton of compute and money. It's also not as efficient. So it's time, compute, money, all of those things. Both are open source. I recommend SQL Mesh because one, I'm biased, and two, I find it better. I've used both, to be honest. And both are free and open source. But if you're thinking in this data product mindset of, okay, we need to own it. I'm willing to do all of these things on top of the data lake. So I'm going to implement Apache Iceberg or Delta Lake or Hootie, but I recommend Apache Iceberg for the reasons we discussed, so that I can be more efficient directly on my data lake, just use the data that's there. Now I can have that open source benefit continued with SQL Mesh or dbt Core. Again, I recommend SQL Mesh to do the transformations and build my models so that I can serve them into my machine learning and AI models. And you need to query it. So you can do several different ways of querying it. You could do DuckDB, you could do Trino, Presto. There's a ton. You could do Apache Spark. It really just depends what your use case is. DuckDB is really great for small data sets, which works great. I know they just created Duck Lake, which is a way of doing a lake house using DuckDB. It's an interesting concept. We'll see where that goes. It's kind of more similar to Hive, to be honest, in the way that it works. Trino allows you to query multiple data sources, which is great. It does query federation. So you could write one query, it could go and pull data from multiple sources, which is fantastic. You could use Spark, which is insanely robust, allows you to do compute at scale, which is great. There's lots of ways to do it. It really just depends. And all of them work with Iceberg. So if you really build a unified data layer where your AI can now just pull from your data lake, all your data's in one spot, your AI can get what it needs in a sustainable way, right? You can read semi-structured, unstructured data and pull it into your AI model. You need to watch for governance and security. So this is the chief concern when I'm helping companies build their AI models is how are we going to govern it? Well, if you do it in a data lake format, this was a concern previously in that many people just didn't have access to the data lake because managing control and access around a data lake was frankly difficult. If you can do it through an Apache Iceberg way, you can do the fine grain and coarse grain access controls. You can do row-based access control, encryption right on the data lake. So it does actually make it easier. That's something Apache Polaris provides. So that really generally rolls through the catalog. So like Apache Polaris, the open source metadata catalog, provides role-based access controls, for instance. Again, open source. There's other alternatives out there like Amazon Glue. Awesome catalog. It's proprietary, right? You're paying for it. So you gotta balance your needs. If you're just on S3 or you're in the Amazon ecosystem and it makes sense to have Glue, then it makes sense to have Glue. But if you're trying to stay open source, then potentially Polaris is the way to go. Project Nessie was another big one for open source data catalogs, but that project is intended to be fully donated into Apache Polaris if it hasn't been already. So again, the open architecture is going to let us have the trusted data. We're going to eliminate silos because now we can do everything straight on the data lake if we need to, right? We don't have to have tons of data warehouses and data marts if we don't want to. We can eliminate some of our ETL pipelines and moving data storage all over the place because we can just do it directly on our data lake. Gives us the flexibility because we're open source to swap out tools as we need. Apache Iceberg also works with tons and tons of tools, so you can swap out your query engine. You can use multiple query engines. You don't have to necessarily choose between DuckDB and Trino and Spark. You could, frankly, use all of them if you want to. You could have multiple data catalogs. right? So it's very flexible. It avoids that vendor lock-in if that's something that you're looking to do. It also helps you be more cost efficient because now, one, you're using open source, and two, you're able to leave your data in one spot and use it all right there. So being able to scale this can be difficult because it's a mindset shift. You need to shift your whole data strategy. It really doesn't work if you're just trying to do a POC. You need to have, in my opinion, leadership buy-in from the top down. So I know we're running up on time, so I'm going to skip here to the end. But AI requires data. It requires the same amount of robust infrastructure and care and CI/CD that you have on your model. The level of risk of having AI go off the rails, in my opinion, is much higher. The best way to implement a robust data process is by using an open source model and by using Apache Iceberg to create essentially a data warehouse directly on your data lake. It enables you to be more efficient. It enables you to have all of those data warehouse benefits that you are looking for and eliminate some of those ETL processes. So I appreciate your time today. Again, we flew through this. There's so many details and different directions we can go in, but that's just really a high-level overview of what I'm seeing of how to power AI using an open source infrastructure, and specifically why Apache Iceberg and open source transformations like SQL Mesh are powering, in practice, they're powering giant AI applications right now out in production. So I appreciate your time. I think we have just a couple minutes left if there are any questions.
To be honest with you, Andrew, you just did an amazing job. The thing is, you still have 15 minutes to go. If you want, feel free to take 5 or 10 minutes to elaborate on any topics you just skipped. But if you have to go, I do understand that, because the session will be recorded and it will be shared across all our members.
Perfect. I do have to drop right at the hour.
Yeah, then thank you so much. It was a pleasure to have you. And we hope we have you back again next year. Thank you to all attendees. This session will be published on our YouTube channel, and we will communicate you as well. Enjoy the rest of your day, night, and or weekends, and see you next week. Thank you. Bye-bye.